So next we have a lightning talk from Giulia Vilone, a research-driven AI specialist with over 15 years of experience. Giulia holds a PhD in artificial intelligence from the Technological University of Dublin, where she focused on explainable AI and argumentation. And her career, which has included roles at Analog Devices, Tobii, and Crown Global, has seen her apply machine learning, computer vision, and big data solutions across robotics, automotive, finance, and public health. So thank you, Giulia.
Thank you. Can you hear me? Thanks for the nice introduction. Thanks for having me. My name is Giulia. My expertise is in explainable AI, and I'm giving a brief presentation on what explainable AI can do for achieving the SDGs. When I was searching for making this presentation, I found out this interesting report from the McKinsey. They collected 160 cases where AI can so technology can benefit societies, and 135 of them, more or less, can be mapped to the SDGs. And as Kate said, with great powers come great responsibilities, so that's not, unfortunately, that's not risk-free. There are risks, but Kate also already spoke about, like the fact that we have environmental impact for the data centers. We have bias, discrimination, and manipulation that unfortunately can be integrated in the way we train our models or in the data if they are not checked thoroughly for biases and discriminative information. Privacy and surveillance, especially for face recognition. I don't know if you follow some work of Amnesty or other NGOs. They have a lot of reports also on how AI can really limit our freedoms. And then there is the growing concerns of job displacement and social unrest. But yeah, one of these possible solution is explainable AI. Explainable AI is this new branch, well, not so new now, of AI that is seeking ways to explain in a very effective, understandable, and intuitive way what the models do, how the models work. They are so big that it's really difficult to understand. So you can understand the small parts of the models, but getting the full logic of the model works is really hard. But with XI, we can increase transparency of the models to make them more understandable, increase human trust in the models. So if you understand how they work, you should trust them more, especially if you know when they don't work. That's the best thing, when you shouldn't trust them. That's what we really want to highlight. Increase accountability, so ensure that they work in an ethical way. And then there are also some legal requirements. I don't know if you have ever come across like these two, the GDPR, of course. Now there is the new AI Act, and both regulations in the EU are demanding that there is some sort of explanation. So for instance, if the computer says no to a loan application, you have officially the right to challenge it. So go to the bank and say, well, tell me why, and why not, and what do I have to do to change the outcome. So yeah, there are, I'm not going into details, but if you want, there are, ask me questions there about this. So what are the, also we have now the new models like LLMs, VLMs. They are becoming big and massive. So XI is also struggling to stay behind these innovations because it's really hard to explain these models for 4 reasons mainly. Because first of all, they are very big, complex. They have also complex data that they include numbers, text, images, videos, and so on. How to explain how these models work when you have such a variety of inputs, outputs, and also parameters in the model. Plus, most of the models like ChatGPT, they are opaque, like you don't have access to the model itself. Unless it's an open source model, you don't know what's inside the model, the architecture, so that becomes even harder. And then there is interactivity, and now before the models were input, output, one output, yes, no, this is a cat, a dog, if you are in computer vision. now you have interaction, so you have a dialogue with these models, the generative AI models. So you ask question, you get an answer, you ask another question. So there must be a way also that during this dialogue, there is a mutual understanding between the human, the user, and the AI. It's hard to evaluate, so the complex, the output is, of course, it's even harder to evaluate when explanation is good or not. Yes, thank you. It's because we don't know what an explanation is, when an explanation is better than another one. Even with simpler models, that was already hard, and now it's becoming even harder. And then there is the risk of ethical violation if you get an abusive behavior from your model. Chances are that the explanation might be also abusive or offensive. Hopefully not. But then there is this new trend, I don't know if you have heard about DeepSeek, that they are trained to also show what is called the chain of thought, thinking that could be enhance explainability, because what happens is DeepSeek shows you the steps that the model should follow to get to the answer, like in a way that mimics the way humans reason. But again, so if you think, oh, that's it, explainability achieved, be careful, because first of all, there is the illusion of transparency. These are those chain of thoughts is part of the training. So they inject data with the chain of thought, and the model is trying to follow what is learned during training. But you don't have the guarantee, it's not guaranteed that those chain of thoughts really represent what the model is doing, how the model is reasoning. Then there is, of course, the amplification of biases. If the data are biased, those chain of thoughts might become, it might increase the bias, and they might present it in a way that you don't detect it, because it seems logical. You follow the steps, and it seems following a logic. They are not deterministic, so if you try maybe to run the model several times, multiple times on the same input, may get different chain of thoughts. So this means that there's no causal relationship. So it's just the model trying to increase or optimize the answer. And then in critical domains like healthcare, it's not proven, it's not guaranteed that the reasoning process is based on evidence or knowledge. So again, it might be, well, it's based on the data that you injected, but it might mix and match things that are not logically related. So be careful on that. Now, a bit brief overview on what XI do now, what are the methods, what solution you can avail of. There are, broadly speaking, 4 types of methods that you can use for generative AI. One is feature attribution, so basically they will tell you this part of the input is relevant, this part of the input is not relevant, so the output is based on this and not on that. Sample based, so they take 2 samples or multiple samples, look at the differences and see what's the output of these differences on the final output. So what's the relationship between input and output by checking for differences in inputs and outputs. Mechanistic, that's basically that's the dream. Take a model and find an algorithm or a way that describes in a simple way and understandable way the model itself, how the model works. And then probing basis, basically that's the way, like you try to ask the model some specific question to understand what the model knows and what it doesn't, what it's guessing. So trying to figure out a smart way to play with the model. Now, an example based on, this is a sample-based, GradCam is one of the most widely known XI methods that are used. Probably you heard about, if you come across any XI paper, you have read about Lime and Shap, but there's a war behind them. These are the 2 methods that everyone talks about, but just to give you a third one, GradCam, was developed for computer vision. Now you can use it for VLMs or LLMs. What it does is basically highlights, as I said, the areas of the inputs, in this case an image, that are where the model is focusing on. So try to figure out what the model is looking at when producing the output. In this case, I took this photo. And this is a famous case of this guy who was a lion tamer, and then the lion were left in the wild, and then they met again the lioness. So jump on him to celebrate it, the fact that they see them again. Anyway, this is the photo of that. And I asked them, I injected in a very small VLM because that has to run on my laptop. They didn't want to burn down my house. So has to overeat. So, okay, tell me, I have a photo. My description is a man is scratching a lioness fur. Show me what you are looking at. And you can see that when with the word man is looking at the man face, when they were scratching, it's at the ends. More interesting also if I get the lioness. I don't know why the lion S part was messed up by the model, but it's looking at the lion. So good, there is a logic. The cons of this, the good thing is one example. You don't know exactly what the model will work on in the rest of the world, so other images, scenarios, and so on. But at least in this scenario, yeah, the model is doing what you're expecting. So in conclusion, what XI can do to achieve the SDGs, yeah, increase the trustworthy, make AI more trustworthy by explaining how it works and making citizens and stakeholders capable of understanding and challenging it when you get some bad outcome. Reducing inequality, because if you know how the model works, you can detect the biases and the discrimination. Responsible consumption and production. If you know how the model works, you might get a better chance to reduce it, to get smaller models that are less energy demanding. And then strengthening an institution, again, if we know how the model works, like people using it, they can control them better, and you have a better also collaboration between the machine and the humans. And that's me. Thank you.
Thank you, Giulia.